Okay, welcome everybody. We are going to go over what is on the computer graphics final exam. So I am putting together this little final exam review sheet while I'm talking. And what I'm going to do with this is put it up on the bhacker.com website and post the video. This is also being recorded. So you'll have everything you need to know for the final exam, so you can do quite well. The final exam will be either, you can decide, well, for this particular course, we're supposed to take it on Wednesday, on Monday, 12/12. If you want, you can take it on Wednesday. All of the exams will be offered on 12/12 and on 12/14 from 10 o'clock in the morning till 4 o'clock in the afternoon. So you can pick a time that best suits your needs. So if you come, this particular class starts at 5. If you come at around 4, we're not going to throw you out on Monday. We'll probably stay longer on Monday. So if you get through the door by 4, we'll let you stay and finish the exam. So if you want to take it at, are you going to be able to come at 4 or 5? Oh, okay, good, yeah, you'll come earlier. Okay, very good. Okay, yeah, come earlier the better is what I'm saying. So get through the door by 4, about the latest. So exam will take you about 1 or 2 hours, probably less. Actually, the computer graphics exam is pretty short, I think, actually. The exam is closed book, closed note, closed internet, closed neighbor, closed everything. You must bring a photo ID when you take the exam because we are checking IDs to make sure that the students who are taking the exams are the students who are in the course. Nobody's taking it for their friend. The exam is worth 25 points, and it is also 25% of your course grade. All assignments are due on Monday, 12/12. It's a week from today. You need to complete 3 out of the 5 assignments. And I had the syllabus up a few minutes ago. What did I do with it? It is still here. Originally, if you look at the syllabus for this course, the final exam here is the 25%. The CSLO essay is 25%. That's been posted a while ago. The assignments, and there's a midterm that was also been posted about halfway through. That's worth 25%. The assignments, which you've got, were 5 originally. Now you only have to do 3 of the 5. Pick the 3 easiest ones you can possibly find, and only do 3 of them. If you do all 5, you can get extra credit, but it's only worth 25% total. So kind of a lower end. Well, the assignment's extremely hard actually, but they're sort of a low percentage of the score. So if you don't do so well on them, you don't have to worry about it. So turn in 3 of those 5, and you don't have to have extremely good works of art either. Make an attempt to complete them. If they're not fully functional, that's fine. It means that you it's basically a way of getting some hands-on experience with it. But I don't want you struggling to the point where you can't finish any of the other work. So if you turn in, give me something, give me a close attempt, and you'll probably get full credit on it. So what I'd like to do now is go over the final exam question by question and tell you what is on the final exam. So the final exam here is, as mentioned above, it is worth 25 points. And I have it in front of me right now, and I'm looking at it. And it's approximately 4 pages long. And it is 25 multiple choice questions. So let's see. Number 1. The exam contains only 25 multiple choice questions. Each question is worth 1 point. One point each. That's the easy part of this review. Okay, so number 2. Now I'm going to go through each one of the questions. So question number 1 is about the field of view of a pinhole camera. So know about the POV, which stands for field of view of a pinhole camera. So what I'm going to do is give you the buzzwords that you can take and look up in the lecture notes or on the internet and kind of get a feel for these terms. And then the questions themselves are very easy. I think they're extremely easy, but the wording of the, as an example, field of view might throw you off. So know what that means. I want to know what a pinhole camera is, and that's all the questions actually come out of the lectures as well. So you have select one that applies, and it's a multiple choice. So question number 2 is about projection techniques. So know about projection techniques. I will also be posting this Word file that I'm typing on the bhacker.com, and I'll put a link there as well, so if your notes aren't so good, you can use my notes. I can take notes for you. But don't feel free to make your own. Some of the projection techniques that you should be familiar with, some that you, because there's a lot of them actually, you should be familiar with are the orthographic. I'm giving you the buzzwords to kind of look up. Axonometric. I spelt that right? I did. Oblique. Etc. Know the differences. Know the differences between these different techniques. Because question number 3 is also on the same, and 4. So question number 2, 3, and 4 are all on the same topic. So I'll just put here, there are 3 questions on this topic. That was just quite interesting. So know those 3 at least. So question number 5 is on transforming. When transforming a blah 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 blah. So know about transformation. Transformation techniques. And what happens when an object is transformed. Basically adjusting the positioning of the image object within the XYZ plane, transforming it from one position to another is what that's referring to. There are just one question, it looks like, on that. And there is another question. Question number 6 is on clipping. In fact, we just had that lecture very recently. Know the concept of clipping. And clipping planes. We just had a recent lecture that covered this. It was one of the last couple of lectures I went over clipping, and we saw that we specified some clipping coordinates, and the parts of pieces of the image were either inside or outside, and we discarded things that were, and clipping essentially gets rid of stuff that's not viewable, makes it so we don't have to render it, makes it more efficient when transforming and rendering, essentially. Breaks down, adds fewer items to the graphic pipeline that we have to process if we're going to do it before, in terms of before the processing occurs. So the concept of clipping planes, there's an entire lecture. In fact, you'll find all of the answers in the lectures. So let's see. That was page 1. Page number 2. I just noticed page 1. There's a fix that. Page number 2. In OpenGL, there are several different matrices. And I have discussed 2 of them in class. And the concept of matrices. So let's see. Know the concept of matrices as they apply to computer graphics and OpenGL. know the common functions. For example, the GL rotate EF, GL model view, GL projection, etc. in terms of the matrices. This could go out. That's all right. I'll just leave that alone. I think I've spelled it correctly. But the matrices and the matrix concept, essentially, and those functions that are supported. There are 1, 2, 3 questions on that. So there are 3 questions on this subtopic. Matrices. No concept of matrices. Okay, there we go. So that's a significant portion as well. So we got 3, 6, 9. We're almost halfway through the exam, believe it or not, in terms of content area. For question number the next 4 questions for 10 through 14, there's 4 questions that are on lighting. In fact, I'll read you this. I'll read you the question, actually. I'm not going to write it in the outline here, but I'll read it. For the next 4 questions, match the pictures on the right with the corresponding term on the left. The arrows in the pictures denote light rays. The dashed line represents the material type to be considered. The key is in the interaction of the light ray with the material. Match A through D with questions 10 through 13. And we have some rays that are going through the material. We have some that are bouncing off the material. We have some that are passing through, but not as much. So you want to know the different type of lighting. So be familiar with the different types of lighting models and techniques. For example, know specular, diffuse, transparent, and translucent. Did I spell specular right? Specular. I think I did, actually. I'm going to add it to the dictionary. So hint, hint, the words that you're going to be matching up with the pictures that are going to show you the different types are specular, diffuse, transparent, and translucent. Practically giving you that question. So know what those are. Have a visual. Know what they look like. In fact, I'll show it to you. It's too far away to see it, but you see how the pictures are. Okay. You're matching the pictures up with the definitions. Yes, and these are the definitions. These are the 4 of them right here. So that was a give me on 4 different. But look it up so you know what it is. All right, that was like question number 10 through 13. Moving right along to page 3. Okay. There are 3 questions. There are 3 questions on, and I covered this in class actually, prong on the Phong, if I'm saying that right, reflection model. I know that I have spelled this correctly, although it's not defined in classic Word. And I'll read you one of the questions, actually. I can't read you the answers, but I can read you one of the questions, or part of the question. The Phong reflection model simplifies light-matter interactions into essentially 4 vectors and a number of constants. Which piece of the prong model is responsible for giving spheres their bright white spots? And then you have 3 options to choose from. And then you're going to have in the Phong reflection model, there's different characteristics, true or false. In the Phong reflection model, there are 3 constants, A, B, and C. Which one is used to describe the qualities of which of the following phenomena? Pick one of the above. So the lighting, the reflection models, no. The reflection model types, for example, I shouldn't say column, reflection model, what do you call these things? Characteristics. For, I think this example, ambient, diffuse, and specular. We're looking at lighting models again. Those are the 3 in particular that we covered in the course that you're going to want to be interested in being familiar with. Okay, moving right along. That was actually 1, 2, 3 questions on the Phong. 3 questions total. Question number 17. As discussed in class, when obtaining normals for a triangle, which of the following mathematical constructs is not used? So let's take a look here for a second. Basic mathematical, it's not going to ask you to calculate, it's just going to know the name of the mathematical technique. Constructs for obtaining normals for a triangle. And I'm going to put normals in quotes here because normals and the concept of normal is something you want to know too. Know what normals means in concept, the normal position. All right, number 18. Which of the following is not a modern application of computer graphics? That's an easy question, actually. You know, I can read you the question, I just can't give you the answer. So, no basic computer graphic, I know this is too broad to say, techniques, concepts and techniques. If we didn't discuss it in class, you don't have to know about it. If we discussed it in class, it's going to end up being one of those options on the multiple choice. And if you were listening or if you have attended the class, you're going to get that. It's a very easy question, actually. There's one on a graphics processor. And the question actually goes, graphic processor or GPU speed is judged by. So, know how to judge graphic processor speed. It's a factor that's going to be influenced with something having to do with what's being rendered. To judge, essentially. It's one of the beginning lectures, actually. This information can be found at the beginning of the course, one of the earlier lectures. That's actually the end of page 3, believe it or not. Page number 4. All of the following are attributes of OpenGL except, so, no, some of the OpenGL attributes or characteristics. That is, what does the API work with? or do in concept. A feature, I'm not gonna, it's actually kind of a basic question. It's not something that is gonna trip you up. There's a question on color. There is one question on color of an object. There are no questions. Let's see. There are no questions on OpenGL function calls. There are no questions that involve writing or reading OpenGL source code, OpenGL or other source code. All the questions are concept-based, all theory. All questions are theory-based, not implementation, like in the assignments. So. Well, what do we have here? So that's the OpenGL. Know the parts of a after I said that, of a typical OpenGL program. That is the basic layouts of the functions, layouts of the structure and functionality of a hello world program. That means, you know, that probably means the inits and stuff, you know, the basic component, the display, yeah. That's what I'm talking about. If you've ever written an OpenGL program, you know the answer to that question. Or if you've been coming to class, you know the answer to the question. If you're not, take a look at the hello world examples. Take a look at the hello world examples and videos from the beginning of the course. That's where that question is coming from the beginning of the course. Or do the programming assignments that are due for the course. In there, well, you have to use the basic technique. Okay, so now we're on number 23. We only have 1, 2, 3 questions left. 23, 24, and 25. 23 is on clipping. And it's talking about, actually, you know what? I'm going to come back up to the clipping question up here. I'm going to add this to the clipping question. Did I not write down something about clipping in here? Clipping planes, okay. You just had okay. No? Okay, so under clipping, number 5, element, question number 5, or item number 5. Know the concept of the Cohen/Sutherland line clipping model. That was also discussed. In this clipping lecture. Just be familiar with the concept of what it's doing. So line clipping as a concept as well. Know what line clipping as a concept is. Okay, and I'll show you the picture here actually. You'll get something like that. You'll have to be told. Which of the following 5-line segments can be trivially rejected on the first pass of the Cohen-Sutherland line clipping? That's right out of the lecture, actually. All of the questions come out of all of the lecture notes for this course, by the way. Every one of them. You do not need an extra book or anything. All of the lectures. Okay, so number 24. Hidden surface removal. So I'm going to go down to the bottom here. There is one concept question about hidden surface removal. Which of the following is not an object space hidden surface removal algorithm? Be familiar with the object space in particular. Hidden removal algorithms. That's a give me. Because I just read the question. The question says, for those of you who didn't hear my muttering, which of the following is not an object space hidden surface removal algorithm? So know which ones are, so you can know which ones aren't to answer the question. And the last question, last but not least, question number 25 on the exam was a true or false question. It's about OpenGL. It's about OpenGL. It's a basic question, actually, about OpenGL. I can't read you the question because the question is true or false, and that's not going to... So I think I mentioned up here something about OpenGL. We covered a lot of OpenGL in the course, so know some of the OpenGL attributes and characteristics, and what is, that is, what does the API work with or do in concept? Yeah. What is OpenGL used for, etc., which is what that question is. So as I kind of review my notes and I look at it and I kind of ponder, what I've taken is the basic concepts that I covered. Everything on the exam was mentioned in one of the lectures that I went over. So I know that there are tons of lectures that I did not go over, and none of those are parts. So if you've been paying attention, actually all you have to do is go on YouTube and see which ones of the lectures. It's not too hard, actually, to count out which lectures I actually went over and review those lectures. And every one of the questions comes out of one of those lectures. So I made it extremely fair, and I tailored it towards the content that I covered in this course, because there's like 50 or 60 lectures. I didn't go over all of them. And then there are no source code examples, so you don't have to worry about that. Let me make sure I save this, actually. There's no tricky questions either. In fact, a lot of the multiple choices only have A, B, and C. You know, I hate it when the teachers like give you 10 different options. And 2 of the options of the A, B, and C are extremely wrong. One of them is right. So it's not what I would call a trippy. It's not going to try and trip you up. It's very straightforward. If you go through the items that I just mentioned here, this is the exam as I read through it, question by question. And you can see there's a lot of similarities. Some of the stuff, let's say for example the normals, I didn't really cover normals that much. You might find a little bit of internet research, or you might find going through some of, I know I had a lecture on the normal face position that I may or may not have covered in a lot of detail. I can't remember if I did or not. But if you're not finding the information, in fact the GPU stuff is in one of the earlier hardware lectures. If you search through the PowerPoints and you can kind of pinpoint which lecture by the title of the lecture is probably going to be helpful. Or just do a word search, you could probably find the lecture that's going to cover the stuff on normals. Everything else actually comes out of lectures that I specifically spent a significant amount of time on. So, no questions related to any of the programming assignments either. So it's not going to be, you know, how did you make your windmill? Or nothing about rolling hills or anything like that. So. Are there questions about the questions? Or questions about the content? Questions about the content that's not on the exam? Well, that's hard to say. For my operating systems class a few minutes ago, or earlier today, I gave them questions that weren't on there. But to give you questions that aren't on here is going to be way too time consuming. There's more questions that are not on here than there are questions that are on the exam. So, I mean, there's only 25, and it's pretty much pinpointed in these areas. I didn't ask you a lot of questions about color. There's only one question on coloring, and it's not even on any of the coloring models. So nothing on shading, nothing on ray tracing. Actually, I guess I could give you, here we go. Questions not on the exam. Not on the exam. So, nothing on ray tracing. Nothing on shading. Or nothing on the rendering pipeline. Nothing on the rendering pipeline. That's a big no-no. Nothing huge on image transformations either. Nothing on world coordinate order. Nothing on the coordinate system. Now I'm thinking of all of these topics I could have added. Coordinate plane system. Nothing on, what were you saying? Coloring, shading, lighting. There are a couple of lighting questions. Modeling images in a world. Modeling images or shape objects. Oh, nothing on texture mapping. Nothing on texture mapping. Modeling objects in a world in relationship to other objects. Nothing really big on transformations either. One question on the matrix, but nothing on, there's a matrix related question, but there's nothing really on the concept of transformation. Well, there's a basic question on transformation, but not like a technical question. No math or technical types of calculation questions. Technical calculation. Wow, I did leave out a lot. Well, it tells you what not to have to worry about. No robot like putting pieces together either. So in terms of the plane, but that's more like this world question. Well, I guess it's going to be difficult for me to go through the entire area of computer graphics and tell you what's not on the exam. But I know those for sure are not on the exam. But I mean, I'm sure I can come up with a list of more topics that are not on the exam, but that would be way too time consuming, I think. So we're going to have a short class today, actually, because this is all we're doing today. We're just going to go over the final and leave you with time in your day today to finish up all of your assignments. To continue working and getting everything done for tomorrow, or for next week, a week from today, on the assignment due dates. If you're struggling with the assignments, I would do the CSLO and the midterm over the assignments. Higher point value. 50% of the course right there in the midterm and the CSLO. Assignments are not worth as much as you'd think they would. But given the amount of time of work that's needed for them, it's not. But the problem is a lot of students can't do the assignments. So if I made them a majority of the course, everyone would fail. So they're a very small percentage of the course. And I will take practically anything. I will take anything not working, and you'll probably get full credit for it. Are there any questions? Anything, did I leave anything out that you can think of? No? Then we're done. All right. So if you don't want to take it on Monday, you can take it on Wednesday, the 14th. Both of the days are open for all sections, and the time is open between 10 o'clock a.m. and 4 o'clock p.m. If you're taking multiple classes with me, you can take multiple exams at the same time, come in at 10 o'clock in the morning and stay all day if you want. You're not limited to 1 or 2 hours. You can take as long as you want, but it is closed book, closed notes, closed internet, closed neighbor. It will be a quiet environment in the room, and you will have to show your ID, so, unless I know who you are. So. If there aren't any questions, comments, or concerns, we are done for today. Done? Okay, we're done. I'm going to stop the video.
Sir,
yes? Oh. I'm going to put it on bhacker.com. It will also be, I'm recording this as well, and we'll also put the video out. In fact, I'm going to do it right now. Put the video and also put this file out there so you can get it. And actually, I can tell you where I'm going to stick it exactly. It will be, as soon as I get, it'll be right up here. I'm going to put it right underneath the syllabus. You'll see the video recording and you'll see the document that I just put together. And for this particular exam, I think this is very important actually, because this is a huge topic area. So, and momentarily, as soon as I end this recording, it'll be right here. Okay, we're all done.